Okay.
There's Mihika.
Yeah, okay, she's also here. Okay, so like, what do you guys know about this one? If I give you this problem, like, and then give you like 5 minutes, can you,
Vieta's theorem. If I remember it, I can do it.
but do you remember anything about the fourth degree?
So I
Fourth
got
degree.
nothing. Other than the fact it's basically like the square of a.
Yeah, it's basically the square of a square, so you can just put it like that and do it.
Okay, you could do that, but okay, another way of asking, like, do you guys know how we got the Viet's relation in the first place for the quadratic equation?
Like how we proved it.
Yeah, how we get those like relations.
I remember I watched a video about it, but that was like a year ago. So
Yeah,
no.
Because what? Sum and product, right? So
Yeah,
when
some
you add it, right, the plus and minus, the roots they'll cancel out.
okay, the question is why? Like, why does some of the solutions are
he's
negative?
asking for the proof, Vid.
Oh, so just rewrite, use the quadratic formula, okay? And rewrite it's what? The quadratic formula is negative b plus or minus the root of b squared minus 4ac, the whole thing divided by 2a.
I see. Okay, I got that.
So
Okay,
that plus and minus, right? When
Mhm.
you add the two different fractions, the plus root and the minus root, those roots will cancel. So then you have negative b plus negative b, which is negative 2b, and over 2a. So negative 2b over 2a would equal to negative b over a.
that is correct. This is good. I like that. But there's another way to approach that as well, which is better than the quadratic formula itself. But yeah, you're correct with that reasoning. So here's, I'm gonna ask you guys another way to look at it. So if I ask you to factor this, like let's say we have two factors and equals 0. And if I ask you the solution, you just say this is 2 and you have 3, right? But if I ask you this backward, like if I give you a solution and tell me the equation, like if I give you these two numbers as the solution, if I tell you to tell me the equation, you can just say x minus 2 times x plus 3, which is x minus 3, which is x plus 3. You can say that. But if I ask you, list the solutions, like R, let's say, I don't know, like S and R, let's use these two variables. And quadratic we can write as x minus s times x minus r, right? And this could be equal to 0. And you may have something in front, like a number like 2, 5, something. But when you multiply, it doesn't change the root, so which is why we don't really care much. But if I expand this, so you will get x squared minus rx minus sx, which is gonna be s plus rx, and plus r times s. As you see, this number right here, the number in front of the x term, is the negative version of the sum. And this number right here, the product of the solution, basically. Which is I want you guys to think about this way. The reason why I'm asking this, because if you do have the third degree or fourth degree or fifth degree or 10th degree, you can still use this approach. So for that reason, let's think about this question. Like we are told, 4 real roots are A, B, C, Ds, which means I can just say x minus A, x minus B, x minus C, x minus D equals 0, right? And you may do multiplication. Since this is the first time, I highly recommend you do this on your own, even though you just see how it's been done. So you really want to kind of get that and use on your own. So if I expand these two guys, you will get x squared. And you can just say like xb, ax, and then ab. So you can just say a plus b x plus ab. And then if you do the same thing with the last two, so you will get x squared minus c plus d x plus d c or cd. And this is equal to 0. But before we kind of move on to expand this more, we can actually do this multiplication way better and without expanding. Do you guys see any way to like find the final answer without really writing those steps?
Can't you just find the solutions of the quadratics?
Say again?
You can use maybe the solutions of the quadratics and then do it.
We could, but let me ask you.
It's the same thing. Never mind.
Like if
Or like maybe you can combine like, for example, 7x cubed plus 7x, so you can do like something like that.
For now, just ignore the problem for a second. I'm trying to get a like general expression. Like ignore the question for now. So like if my question is, if I ask you to expand this, like without really multiplying all these terms, can you find it, like tell me the final answer without really expanding those? Like what I'm saying that if I expand this, you know, x times x times x times x, we have x to the fourth power, right? That's the first thing. And then there is no other ways to get to the fourth power of x. That's only one term. But if I want to ask you now, how many ways, like, can you get x to the third power? Like you can multiply x, and minus d, which will be minus d x to the third power. And if I multiply minus a by x by x by x, you will get minus a times x to the third power. Do you see what I mean?
Okay.
So if you keep doing this, your second like term will be this: a plus b plus c plus d to the x to the third power. Does this make sense?
Oh.
Let me repeat one more time. So I multiply, like my thing is like when you expand this, you are gonna get x to the fourth, x to the third, x to the second, x to the first, and x to the zeroth power. So my question is, without really multiplying all these middle like tedious like brute force, can I just get the final answer immediately, which is what I'm trying to do? If I multiply x, and x, which is x cubed, and the last term, I can take either this one or this one. If I take this one, I got the first term. If I take the negative d, then I will get negative d x cubed. But if I multiply x, negative c, and x, I will get minus c to the c times x to the third power. And if I do this for every other like combination, like every time you are gonna take either like x or negative a, b, or c, or d. One of those two like terms you should be like multiplying basically. So does that make sense?
Yeah. Okay.
Okay, if you don't really get this, I will let you multiply this on your own just to get those results. And the next one, I will get x to the second power. But in order for us to get x to power, like let's say we are gonna take x from this binomial, that's already x squared, which means I should take the negative c and negative d from the other two binomials, which is c, like negative c times x squared, and then negative c, negative c times negative d times x squared, which is cd x squared. And if I take the x right here, x right here, x right here, and d and b right here, so you will get bd x squared. And if I just do the other way around, so you are gonna get the next term as like ab plus ac plus bc, like plus bd plus like maybe cd, I guess, if I'm not mistaken. So you are gonna get this as the coefficient of the square term. Does that make sense?
Guess so, yeah.
Okay. So far, so good, right? So we're good. But make sure that we do have negative right here, but now it's positive. The reason why we are getting this positive, because like you are taking the like two of these like four product, the x terms, and then you got negative c and negative d, or negative a and negative c. You are multiplying two negatives that will make a positive. So which means every product in this second part is gonna be positive. So which is why this is positive. So now you're gonna find the x term, which means one of these four binomial, you are gonna choose the x, and other three, you're gonna choose the constant term. So if I choose x right here, you're gonna choose minus b, minus c, and minus d. If you multiply those, you get minus b, c, d. So you're gonna multiply those like a variable, like three of them together. So you will get the next term as, but negative, as if I choose the ABC and ABD, and you get ACD and BCD. And then all these terms will have X as well. And then that will be negative because two of them will make a positive, but the third one is still negative. And the last one, if you want to get the constant term, you're going to take the negative A, negative B, negative C, and negative D. So that is like four of these negative values, which will make positive. So you will get A, B, C, D. And this is equal to 0. If you really survive with this multiplication, then you got the point.
Yeah, then I got, then the answer would be 7/4, correct?
That's it. That's it. So if you knew this before, then this question, which is, I guess, number, I don't know, 25 on the test, which is a state level test, you could do this question in less than 5 seconds or maybe 10 seconds.
If not, then you can have an extra Mexica waiting for you.
Yeah, she just joined in a different account, which is, I guess, was trying to log in.
Wait, so then so wait, the way you started, you just plugged in A, B, C, and D into. But we don't know what A, B, C, and D is, right? So then how did you like? I didn't.
We don't care about
One
those.
over A plus 1 over B plus 1 over C
Yeah.
plus 1 over D. I simplified that while he was talking. And I got this the you know the number before the X. For the X term, right? You have these like triples, right? That sum is going to be -7. So that's your numerator. Your denominator is
Oh.
A, B, C, D, which is -4.
Wait,
Oh
how do
yeah,
you
I
know
see
that?
what you did now. I see.
-7 over -4, you get 7 over 4.
How do you know their sum is -7 though?
Because Drew, look. So for if you see the X cubed section, right? It's A plus B.
No, not X cubed, the X, just the X. Regular
Yeah,
X.
sorry, wrong section. The X section, right? If you plug in if you like
Plug in the value.
yeah, plug in the values, right? You'll get 7 or X, like in that case.
Oh, okay.
So the
Go ahead.
is it wait 1 second.
The numerator will be
Yeah,
that.
the numerator would, if you would like simplify it, right? Then you would get this equation as your numerator, which is 7.
Yeah, so let me go ahead and one more time just to be on the safe side. So I did the work right here while I was talking, but let's do this again. So what I did was I multiply each fraction by something so we can get a common denominator. I multiply the first fraction by BCD. So you will get BCD over ABCD. And the second one, I will multiply by ACD. So you will get ACD over ABCD.
Oh, yeah.
And then you multiply this by ABD, so you will get ABD over ABCD. And the last one is ABC
ABC.
over
Yeah.
ABCD. So if you add the numerators, the numerator is basically these numbers, which is, if you look at this one, negative version of the coefficient of the X term. So the X term is 7, right? And if you take the negative version of that, that's just -7, so which is your numerator. And the denominator is just ABCD, which is the product, and the product is the last term, which is just the term itself, and the last term is.
Oh, and that's -4 or 7 over 4. Oh, that makes so much more sense. Okay.
Okay, so that is how we can just basically get that. So a couple things before we move on. So this is 7 over 4. If you guys remember the quadratic Viet's relation, some people say Vieta, some people say Viet, whatever. So let's say ax squared plus bx plus c, right? And then the sum was negative b over a.
Over A.
And the product was
C
c over a.
C over A.
But if you look at the fourth degree, the sum of the solution, which is basically our second term right here, like that's still negative version of the coefficient of the second highest degree, which looks like similar to this one, right?
Yeah.
But the product was C over A. The product was
term.
constant. If you had some numbers right here, so you could just divide this constant by that number as well. But here's my warning. So the second degree and the fourth degree kind of has a similar manner. But if I have some middle terms, let's say if I ask you to tell me the sum of these guys, then you are going to look at the coefficient of the square term, not just the product. So, but these are the product as pairwise product, and then this is a product of the triples. So when you have the fifth degree or third degree or the seventh degree, you do have this relation again. But the key is every time the coefficients are alternating signs, which means you start with, let's say, the largest power, like we start with the x to the fourth power as positive right here, right? And this is negative, and then now it's positive, and then next is negative, it's positive, and continue that way. I think, did I mess this one? This is correct, actually, yeah. I just assumed these two are different, but they are the same thing. So that sign is alternate each other. So if you have the third power, okay, so if you have the third degree, basically, your sum of the solution will not be negative b over a. It will be just b over a. Does that make sense?
Yeah, okay.
So in order for us not to confuse each other, then I highly recommend you to do this if you are not sure, even though it's gonna take a while, like a bit longer, but you don't wanna mess up with the sign, because if you just take this as itself, 7 over -4, that's different answer. Even though you know a lot of stuff, you don't wanna mess up.
So it's probably not.
What's that?
Wait, what did you say?
I said nothing.
Okay, are we good
That's
so far? Okay,
Yeah.
are we good now?
That was the ghost that just came out and started saying, it's
Okay, it's-
probably not. Who
Okay.
was this?
That's fine. It was a best, I guess, close and something.
Sounded like
Okay, so here's the next one.
Power divided by
You
10.
have this question meant to be the challenging, like more challenging than the previous problem, but let's see how challenging this is.
Oh, damn it.
And you do not use a calculator at all for this. So what is your approach? Like, you may probably do something, but what do you guys do?
If you wanted to brute force it, you would probably use Pascal's triangles to find the digits and then
Yeah.
divide. But if you were to like think smartly, you would probably think like the pattern in their modular congruences to the powers of 11, and then
yeah,
figure
that's how I thought you could do.
Okay, like if you try like 11 to the first power, 10 is not correct. 11 to the first is 11 if you take mod 13.
So that's 2 mod 13. That's -2 mod 13.
Okay, that is good. I'm gonna get to that point. So 11 to the second power is already 121.
Yeah, that's 4 mod 13, or if you want
So
to put
like
-9 mod.
91 is a multiple of 13, 7 times like 13, which is 91. And then if you add 13 to 91, that's 104,
Plus
right?
113 and 117.
So 104 to the 120, or like another 13, which is 104, like plus 13, I mean plus 11, which is 114. So you will get 121, which is it 7? Is that 7?
It's -7. I'm pretty sure.
I got 4 mod
Four.
13.
It's 4 mod 13 or -7 mod 13.
So Drew, I know what you are trying. You just take the -2, which is good, but I'm gonna use as a second solution. So that's why I just asked, what is
Oh, okay, sure.
121 is congruent to mod?
That's 7 mod 13. I mean
Is-
4 mod 13 then. Yeah.
Is it 7 or 4? Okay, 4. Is that 4?
Yeah.
Okay. And if you keep doing this, 11 to the third power, you're gonna multiply 4 by 11. That's 44. 39 is a multiple, so 44. So you should get 5, right? Are we good so far?
Yeah.
Okay, and then if I try 11 to the 4, you get 5 times 11, 55. 52 is divisible, so you will get 3. And then you can just keep doing this, but it's gonna take a while. You may not get it easily. Maybe after like maybe 10 power, you can maybe get it. But instead of doing this, sometimes we are gonna use the negative values, which is what we're gonna do. Instead of 11, so we are gonna write -2, right? So that's basically way better than that. So -1 to the first power is just -2, and -2 to the second power is 4. So -2 to the third power is -8. Is that 5?
Yeah.
Okay, that I was explaining better than this. Anyway, so let's continue. So -2 to the fourth power is 16. 16 is 3, right?
Yeah.
And if I take the power second, like the square of this one, then I will get -2 to the
That's
like
4096, I
8
believe.
power.
That's 4096. To the 12th, that's 4096.
Okay, but like, can we just try the 8th power by taking 3 squared as well?
That's 256, I believe.
Oh, like this is 2 to the 4th, right? This is 2 to the 4th.
Yeah,
And if I square this, you will get 2 to the
that's
8th.
256.
And this is equal to 3 squared, which is 9, right?
Yeah.
Not 9, okay. And if I take the, if I multiply this by 4, 2 to the 4, which I,
Oh, then you
and 2 to the 4th was 3, so I can multiply this by
and then
3.
you get 27 or 1
So that will
Yeah.
be 27. 27 is 26 plus 1, which is
or
just
1. Yeah.
1 and 10.
Does that make sense?
Yeah, that makes sense.
Okay. Let me see if I can do something else. I think this is not too bad. Yeah, we can, like, the reason I showed the red solution instead of the first solution is just using the negative. Sometimes it is way better. So which was the case on this one. Oh, are you good with that?
I didn't quite understand it. Can you say it again? Because
Like 11, if you divide 11 by 13, like you can write, like, how do I say that? Like 11 is congruent to, like, 13 more than this is 24. So 11 and 24 are gonna give us the same remainder if we divide by 13. And if I add 13 to this guy, so you will get 37. These three numbers, we call they are congruent to each other, meaning that when you divide these numbers by 13, the remainder is the same. Or if you take the difference between any of these two, difference will be same, basically, because that's the remainder. But instead of going this positive direction, we can do this negative direction as well. If I subtract 13 from this, I will get -2, meaning that all of these numbers congruent each other. So you can just take one instead of the other. So instead of 11 to the 12th power, like this, we just took the -2 because that's smaller than 11 to deal with. And then we start with the -2 to the first power, which is -2, meaning that -2 is congruent to -2 if you take the mod 13, meaning that when you divide by 13, you get a remainder of -2. You can just say this way, like -2 plus 11 times 1. I mean, 11, not 11, 13 plus 1, meaning that when you multiply 13 by 1, you get a remainder of -2, which is equal to 11. So instead of 11, we can just say -2. That's where we start with instead of 11. And then -2 squared is 4. -2 to the third is like -8, or you can just multiply, that's 8, -8. But -8 is if you add 5 to negative, like, you add 13 to negative, like, 8, so you get 5. So which is why we got -2 to the third power is 5. Does that make sense?
yeah.
And then if you take the fourth power, you either multiply 5 by -2 because this was third power. If you multiply by the first power, you got the fourth power, which is basically 5 times -2, which is -10. If you add 13 to -10, you get 3, or you can take the -2 to the fourth as 2 to the fourth, which is 16. 16 has a remainder of 3 if you divide by 13, which is why you can get this number in different ways. And that's 3. As soon as we got the fourth power, I just squared this equation. That is 2 to the 8th power. And then if you square 3, that's 9. So that's why how I got that 9. But I'd like to get the 12th power that, so I multiply 2 to the 4th, 2 to the 4th. So 2 to the 4th was 3. And I multiplied this left side by 2 to the 4th and the right side by 3 because that's the same as 2 to the 4th.
Okay, I got it. Yeah.
Okay, that's good. Miyuka's trying to join, but I hope she's
Hopefully she makes it in time for team round.
okay, let's try the next one. She's here, but I'm not sure if she can hear us.
Yeah, I can.
Oh, can you hear me, Miyuka?
Yeah, I can hear you.
Okay, that's good. Here's the next one. Let me see. I think you're close, but it's not correct. Yes, that is correct. Okay, so Drew, can you explain?
Okay, so basically what I realized I had to do was that we had to make it such that either n over 2 is equal to 1 or n squared plus 1 is equal to 1. The first case is impossible. For integers from 1 to 100 is impossible. Unless you get 0 and assume 0 is odd, it's not possible. So I look at the second case. Let's look at just f of n is equal to 1. So the first case would be 2. 2 is even, 2 over 2 is 1. Then you realize that this works for every power of 2, since you'll just keep dividing till you get 1. That's 2, 4, 8, 16, 32, 64, and that's 6. So I thought that was the answer, but then I realized I'm missing something. That's when I realized 1 also counts, because 1's odd, so we do 1 squared plus 1, and that's 2, and then 2 over 1 is 1, so that's 7.
That is correct. So let me write like slightly differently. Like whenever you guys have some question like this, if you have no idea what to do, start with some simple cases, like your easy cases. Like in this question, we are told n should be between 1 to 100, right? And let's go ahead and start with 1. Like if n is 1, then you are going to get f of 1. Since n is odd number, I'm going to use the first one, which is going to be 1 squared plus 1, which is 2. But since this is 2, we can continue, like we are going to apply the f function some number of times, maybe 1 time, maybe 2 times, maybe 100 times if needed. So now you're going to plug 2 for f. So if you plug 2, which is even, so you will get 2 over 2. So that is equal to 1. So if n is 1, then we are going to be able to get result to be 1, which means you're going to apply this f twice. That's good. So if I choose n equals 2, then f of 2 equals like 2 is right here, which is we already know f of 2 was 1, and that means this is also good. And if n is 3, then f of 3 is gonna be like the first one, which is 3 squared plus 1, and 9. If you choose like 9, 9 squared plus 1, so you will get f of 9. You're getting keep bigger, right? So 81 plus 1 and 82 squared plus 1. You're not gonna able to get backwards. So which means if 3 doesn't work, any odd number doesn't work either, because like 5, if you try 5 squared plus 1, you will get bigger value. If you try something else, you will get bigger value. The reason why odd doesn't work because you're going to keep using the first equation, which will give you always bigger value than what you are plugging into, since we are looking for the positive number. So any odd doesn't work. But let's think about 4 now. If I choose 4, so f of 4 is going to be the second one. So 4 over 2 is 2. As soon as we know f of 2 was 1, so that does work then. F of 2 equals 1. So this is good. So 1, 2, 4 actually working. And if you keep doing this, you can finally find it. But look at the relation. All these numbers that actually work is somehow power of 2's. 2 to the 0th power, 2 to the first power, 2 to the second power, and all the way to the 2 to the 6th power. So if you keep using those, then you have 7 of these numbers. So which is why we do have 7. Now you don't need to check all of these. Based on the reasoning that we have, we can just say this is indeed the case. Any question? Okay, so this was number 29 on the test. And this is the last question on the test. Let's see. Okay, so these are what I have so far. So I think that is close, but that's not correct. So we want to find that equal size. Like, what is the first thing do you guys recognize in the problem? Like,
Isosceles triangles, isosceles trapezoid.
isosceles pentagon, like, yeah, I would say, yeah, isosceles, like there is a symmetry, right? If you take the right middle of AB and connect with D, you will get just a reflection over each other, which is useful at some point. That's one thing we can see. What else do we have that could be useful?
You have right angles, so I would suspect that you have to use hypotenuses and right triangles.
And also 120 degrees is also nice angles, right? Because that will make a
When
60
it divides by 2, you get 60. So perhaps when you bisect it, you could use the right angle and find it.
We may do that bisecting, but instead of bisecting 120, can we just use the exterior of that? Because that is 60 degrees, which is a good number to use. Like, what I mean by that, so we can do this, like there is nothing wrong with this approach. You can drop this, like, and then you are gonna see this is gonna be 90 degrees, like perpendicular to AB. You can do that. But instead of doing this, I'll do extend ED in a way that I will get the opposite angle as like 60. And then if I extend the VC, they will somewhere will intersect. So based on my figure, it doesn't look like nicer, but so let's say they will intersect at some point. That is not correct either. So this is gonna be 60 and this is 90, and then the angle at the bottom is 30 degrees. Like if I name this is x, which is what we are looking, the hypotenuse is 2x, and this is gonna be x root 3. Okay, this is something. What else do I have other than these? This is also x, ED. Okay, and like we have the 30 degrees and there is a 90 right here. Like maybe if I extend this way, I will get a bigger right angle as well, like right angle triangle with 36 and 90s. Maybe that might be useful. But what else can we do?
Maybe
So let me, what do you say?
I think if you extend AE, right, and extend it such that the one of the lines that you drew before, right, the one that has the extra 3, such that both lines connect, you form another triangle, like a bigger triangle. Maybe you can find some of the ratios using that between the two triangles.
Okay, so let's do that. So if I extend the EA, and then means I will extend the BC as well. The reason why we are gonna do it, because we do know the angle in this corner at the bottom right was 30 degrees. So this is 90, so which makes this is 60 degrees. So 60 degrees is opposite to like this side, which is 3x. And if you divide 3x by root 3, you get a smaller leg, which is gonna be x root 3. And if you multiply this by 2, you will get the hypotenuse, which is gonna be twice of that, which is gonna be 2 times x root 3, which means this is gonna be x root 3 as well. Okay, this is something we have, but also we know this is 18, so this means x root 3 minus 18. This is 18, and this is also x root 3 minus 18, which means this is equilateral triangle. Does that make sense for that equilateral triangle part? Like, let me repeat one more time. Like, are we good with this
Oh,
x?
yeah, yeah.
Got it. Got it.
Okay, so like since you know we got this piece as x root 3, if you subtract 18, you got this part which is x root 3 minus 18, and the same reasoning, this was x
Yeah,
root
it's just 60 as the not one of the base angles it has.
so that means these are also 12. And
Yeah.
that is 30, so the x root 3 is equal to 30. So if you divide by root 3, so you will get 10 root 3.
Wait,
Okay,
that's it?
that's it.
Yeah.
I thought oh, okay. Oh, yeah, because it's 30. Wait. Mm.
Are we good now?
I thought they were this. I thought they were similar. I thought they were.
Yeah, this is one thing we can do, but here's the another way, which I kind of show you at the beginning, but we didn't do that. But I kind of didn't want to do that as first approach. So think about this figure again. And you know, some of you guys said at the beginning, like 120 is useful because that's something we are given. And then we can connect these two. Since we know this is equal to this, then we do know this is 30 degrees and this is 30 degrees. And then which makes this is 60 degrees. I'm not sure if you know that, like whenever you have 30, 30, 120, if this is x, and if this is x, this EC will be x times root 3. You may just get
Really?
immediately by dropping the altitude and using 36 to 90. But if you remember x root 3, that is also good to remember. But that is something. And what I'm going to do to use this 60, I'm going to drop this altitude. But since this is isosceles, we can drop the alpha from B to the other side as well. And that is also 12. And this is 60, so this is 90, so this is going to be 30. And since these are the same, so this is 60 and 30 as well. So this is 18, so which means this is 9, and this is 9 root 3. And then this is also 9 root 3, and this is also 9. And we have 9, 18 plus 12 is 30. So 30 equals, I said, x times root 3. We can get that x times root 3. But if you don't know that, so you can still do this. Like if you drop the altitude to the middle and you get 60 and 60, and this is the whole thing was 30, then the half is 15. So this is 15, which is opposite the 60 degrees. And if you divide by root 3, so you got 15 over root 3 as a smaller leg, and multiply this by 2 to get the hypotenuse ED, which is also 30 over root 3, which is 10 root 3.
Okay, okay. That makes a lot more sense.
Like this is slightly easier than the first approach if you focus on inside. But the reason I did the other one first, because most of the time we don't think about extending outside. So that's also a good approach to try. So that's why I like to kind of do that either way. Okay. So let's stop here. So that was the last question on the test.